Well, I'm back, and I'm back with my Dunkin' Donuts coffee, because I just went out and got a fresh Dunkin' Donuts coffee. That's hot. When I do mathematics, I like to drink Dunkin' Donuts coffee, because it makes me make no mistakes, and I do wonderful. Alright, whatever. Anyway, kids, I'm not sure if I'm ever going to get a endorsement from Dunkin' Donuts, only because they'll be like, okay, so you're impressing on kids that if you drink coffee as an adult, you become a sort of psychotic fool. So what? Anyway, we are doing Unit 1, Day 4 Bagger. Yes, graphing the absolute value function. Now, you've graphed lines before. I know you know how to graph lines. I know you know what to do with lines. They're kind of boring. What we're going to do is graph absolute value functions. So there is what the function looks like right there. Now again, I'm just going to remind you that we are going to be using the TI Inspire. You can get the TI Inspire for $127 on Amazon or something of that, about that. Or you can also get it for like $27 for the year. So if you know this is going to be a tough year and you know you're going to want the extra support. Now, the $27 a year is for this. It's for a computer program that runs on your computer, and you're going to have a computer around in order to run it. And it won't run on a Chromebook. It has to run on something you can install because it's not an app. All right, so let's get started on this. If you have any questions about that, you can see the webpage. I've got some links to where you can buy that. Just go to nkinfinity.com. You could also go to algebra2commoncore.com. That'll take you to our site, NK Infinity. By the way, if you're wondering where NK Infinity comes from, my last name is Krause. I am Mr. Krause. My partner in crime is Miss Newman. That's the NK, and then we just love infinity. Mostly because we like a lot of homework. So we like an infinite amount of homework. JK, kids. Anyway, let's get started. If you're using the TI Inspire, here's how you get to absolute value. Just go into graph mode, scratch pad for graph mode. You click on this crazy button right over here. I'll try to blow that up a little bit. And if you're looking at it on the calculator over here, you go home. You go into graph mode, so enter, and then you click on this button right here, absolute value, and then you'll see all of this crazy stuff right here. Here's the one we want, that one right there. Oh man, it hates when I click on it with my pen. I don't know why. So anyway, that's how you get it. All right, so if we type in the absolute value of a thing, and you've done this since 9th grade. You did this in 9th grade. If I type in the absolute value of x and I hit enter, by the way, to get to the table, you do Control T. It's a toggle switch, so Control T is on, Control T is off. And you plot all those points, and you get all these points. You'll notice they're all right here. You know, should be obvious what they are. -6, 6, -5, 5, -4, 4, -3, 3. If you remember correctly, I'm not sure if you know what your teacher taught you, but 1, 1, 2, 2, 3, 3. It makes like a V, right? This point at the bottom is called the vertex. That vertex is, I'm not going to do this, we're going to be here all day. And I can't draw straight lines. Oh, that's actually not bad. The vertex is the point 0, 0, or the origin. Its y-intercept is also 0, 0. Sometimes we'll just write y equals 0, but I like 0, 0. The domain. So domain, we talked about domain. Hold on. It was just sitting there calling me. Domain are the values, are the x values. So they're the ones that we're going off in this direction, and we're going off in this direction. And since we go on forever and ever in this direction, and on forever and ever in the right direction, my domain is -infinity to +infinity. Remember, anytime you write infinity, it has to have a parentheses on it. Y values are the lowest Y value and all the Y values that are used. Well, we're starting at 0 and going forever and ever and up. So the range here would be 0 to positive infinity. So the reason we're going to press the tab function is because that allows us to graph two things on the same curve. Now I already have this graphed on my calculator, so I'm going to press the tab button, and the first thing I'm going to do is +2. So we're going to, let me get rid of my table, Control T, and I'm going to hit tab, and I'm going to do absolute value again. Absolute value of x, but this time I'll only look at my notes. I'm going to add 2 on the outside. Yes, blessed. +2. Hit enter. Oh, look what happened to it. So my red one is there in red. My blue one's down here. It looks like it moved up 2. Well, let me press tab again. I don't know why it's doing that. Absolute value of x, get out of that, and then +5. Oh, that moved up 5. Okay. And then let's see what happens when I press tab. And I do the absolute value of x, and I do -3. Now this should become as no surprise. Make sure you don't use this button. This is a negative button. That's not what we want. We want -3. All right, so -3 moved the blue one down. The original was just right here, and this is the original right here. I don't know why it doesn't like me doing that. And then the red one moved up, and the black one moved way up. So if I come over to my graph, +2 moved up here. Why did you do that? So, well, now you're probably behind my head. So if I look at these, hopefully my head's out of the way. +2 moved up here. +5 moved up here. And -3 moved down here. So it should be obvious to you that these are vertical shifts. In other words, we're shifting up and down. And if it's positive, I go up, and if it's negative, I go down. That should be no surprise to you at all. I mean, boom, pretty obvious, pretty simple. That is a vertical transformation. It is a vertical translation. Well, we're under transformation. This is a vertical translation. A translation is just a slide or a move. All right, I'll hit pause and I'll be right back. All right, so now what I want to do is clear what's called my scratch pad. I want to clear my screen. And really the easiest way to do that is if you come over here and you just hit this dock and you go down to clear scratch pad. So you're going to hear me say dock B. Dock B clears all this crap, right? And we'll go back into graph mode. All right, so now we're going to graph absolute value of x again, so it should be pretty easy. Just boom, absolute value of x. Slam that puppy on there. There it is. Absolute value of x in blue. Boy, does it look beautiful. Okay, so now if you notice what we're going to do now, instead of adding the 2 on the outside or adding the 5 on the outside or adding or subtracting the 6 on the or 3 on the inside or on the outside, we're going to do it on the inside now. It makes a large difference, and you got to start to recognize this. We're going to see this pattern over and over again. So I'll hit the tab button, going into absolute value of x, but in this game we're going to add x plus 2. Oh, it moved to the right. No, it moved to the left 2. Let's hit tab again. Absolute value of x. Absolute value. If you're wondering, if I was just using my mouse, I'm using my pen. It just doesn't work quite as nicely as the mouse. I'll undo x plus 5. Oh, I moved to the left 5. All right, let's see what happens when I do x plus 3, or x minus 3. X minus 3. Make sure you put minus 3, not times 3. Oh, That moved to the right. Okay, so let's get this straight. When I add, I go to the left. Okay, for you, I think left is that way, and then right is that way. Okay, gotta have my teacher voice. Okay, so when you add on the inside, we're going to the left. When we subtract on the inside, we move to the right. But it's still a translation. It's just a translation or a slide horizontally. So let's make sure we understand this. This is what happens when I do +2, +5. So this is with +2. This is with +5. It moved over here. And with -3, it moved to the right 3. So this is another, but this is a horizontal shift. So it's left or right. And oh man, I just wrote, sorry, I didn't mean to do that. Horizontal shift. I know some of you are thinking, it's math, I could use the other word. I get it. No, it's not. Sorry about that. Total mistake there. Shift. A little embarrassed. Anyway, it's a translation. It's another translation. Now, the key to this one is I want you to remember it's backwards from what you normally would think. Backwards. And what do I mean by backwards? Well, if I added 5, you would think, oh, add 5, we go to the right. Subtract 5, we go to the left, but that's not true. We're going to add, we go to the left. When we're going to subtract, we're going to go to the right. Now let's go back up to this one. You remember, this one was normal, so this is normal, or what you would normally think. Add, we go up. Subtract, we go down. Remember that. It's important. It's very, very important. All right, let's clear our scratch pad and do this over again. So back here, Doc B, and we go back into graphic mode. All right, so let's see how much time we're at. Be back. All right, I'm back. Now you're probably wondering why I go, and it doesn't even seem like for a second that I go, but I do go and I come back. I do it for 2 reasons. One, little coffee. I know you don't like me watching me slurp all the time, but the other reason is my computer, although it is very fast, sometimes the audio and video get off sync once in a while if I wait too long. All right, so here we go. Our next one. Now this is hard to. I should have put a time signal, so this should be A times f of x, and our A value. Does anybody know what this means? Just raise your hand if you know what this means. Go ahead, raise your hand. You over there in Schenectady. Yeah. Oh, yeah. Oh, perfect. This means positive. It doesn't mean greater than 0. It means positive. And when you're taking your SATs, remember that. They don't care that you know it's greater than 0. They want you to say positive. So when I see A is greater than 0, I'd say, oh, 4. Okay, that works. So again, we're going to go back to the parent function. This is our parent function, y equals the absolute value of x. And it really should come as no surprise to you what happens here. I know you've done some of this stuff in the past. Where is my calculator? There we go. So we'll get our normal calculator in there. We'll get our normal parent function. Anytime you go back to the original, no transformations, no translations, no dilations, nothing. It's called the parent function. This is the parent function of the absolute value. And then we're going to pick 2 as our starting number. So we're going to do tab. Oh. Okay. Not sure why I did that. Tab. Oh, there we go. 2. I'm going to use my mouse. It's just a little bit easier. So I'll go over here. 2. Absolute value of x. Oh, okay. Red. Let me just go. Let's hit tab again. And we're going to do 5 absolute value. Was it 5? 5, yes. 5 absolute value of x. Oh, okay. So when the number is positive, it gets steeper. When the number is positive, it gets steeper. All right, let's do that last one. The last one's positive. 1/2 is positive, so it's going to get steeper as well. So we'll press tab, and we're going to do, and in order to get a fraction on this calculator, you hit control division, and I do 1/2 absolute value of x. So this should get steeper. Oh, whoa, wait a second now. The 1/2, the original was blue. So the original is blue. And then when I put a 2 in front, it got steeper. And when I put a 5 in front, it got steeper. But when I put a 1/2 in front, it got wider. Well, okay, so these are dilations. And what I want you to remember with these is it changes the slope or the rate of change. It becomes steeper or wider. So when x or when a is greater than 1, it becomes steeper. When I'm trying not to misspell things. When a is between 0, it still has to be greater than 1, and 1, in other words, a fraction, a 1/2, a 1/3, a 2/5. When it's some fraction between 0 and 1, it gets wider. But what I want you to remember is that number in front affects the steepness or the rate of change or the slope of this function. It either gets steeper or wider. And again, notice the y-intercept never changed. This is not a translation. It is strictly a dilation. So it got steeper with 2. So when a was equal to 2, and then when a was equal to 5, it got steeper still. But when a was equal to 1/2, it got wider. Okay, remember that. I'll be back. You are so delicious. Well, you're back. Did you clear your scratch pad? Oh, you should have. Doc B. Boom, done. We're going back into graphing. Okay, we're going to do the same thing. We're going to do a times f of x. Now that I'm going to ask you, what does this mean? In this case means a is negative. A is negative. All right, so a is negative this time. So, get our parent function in there. Again, remember, let me go back to my mouse. Our parent function is just f of x equals the absolute value of x. Now we're going to put just a simple negative in front. So tab negative absolute value of x. Oh yeah, do you remember that? When you dealt with parabolas in 9th grade, do you remember what that was all about? Let's see. Our next one would be -3. So we'll hit tab -3 absolute value of x. Enter. Ooh. Okay, so it got steeper. It still got steeper, but it's going down. And we're going to do -1/2. Let's do -1/7. I'm going to try that one just for fun. I'll do something different. Tab. Control division. Ah, it's not right there. Control division. Even my mouse is having problems. -1/7. Just for fun. Absolute value of x. Enter. Oh my goodness, look how wide that got. Okay, so again, it's a dilation, but it's also a reflection in the x-axis and a dilation. Okay, so it's the same as the last time. The only difference is now we've got the reflection, and then it's either going to get steeper or wider, depending on what that number is in front. So let's do a brief summary of our translations. The negative in front is a reflection in the x-axis. This is a dilation. It's either going to be steeper, less than 1, or wider, greater than 1, and vice versa for the negatives. On the inside, remember this is a horizontal translation or slide. This is going to move left or right, but backwards. Remember, on the inside, we're going to be backwards. We're going to do that like 6 times this year, and I want you to really get a good handle on that. When you're adding or subtracting on the inside, I don't care if it's absolute values or parentheses later or whatever it is, it's a horizontal left or right shift backwards. And then when we add on the outside, that is a vertical translation or slide. That's up and down. And then this is normal, which means we add, we go up, we subtract, we go down. All right, so let's see what we got. So normally the vertex is 0, 0, but we're going to move it to the left 4, negative 4. Oh, we should be down here. Negative 4. And we're going to move it down to negative 2. Ooh, that was pretty tough. Oh, I should tell you what transformations are. Oh, what happened? So let me put that back on there. Well, transformations, it's going right, left. Even though it's plus, it's going left 4, down 2. So that's why it's negative 4, negative 2. Number 2, we're going right 1, that's the plus 1, or the minus 1, and up 3. So our new vertex on this one is going to be 1, 3. What transformations are performed on this? All right, so we have a reflection. We have a dilation of 2. We're going to move it right 1 and up 3. Now, these are the only ones that come into play with the vertex. Remember, the dilation and the reflection have nothing to do with where the vertex is. These do. So my new vertex is going to be 1, 3. It's just going to be going down, and it's going to be steeper. So what is the absolute value equation when I have this? So this means we started at 0, 0, and we moved right 5, up 8. So if I'm going to write that function, f of x, right 5, right and left is on the inside backwards. So since I went right 5, that's going to be x minus 5. But I went up 8, and that's normal, plus 8. Oh, I can go down more, come on. Okay. So, we move left, we're moving left 2, up 3. Now remember, it's going to be f of x equals absolute value of x. Now we moved left negative, so that means in the inside we do the opposite sign, plus 2 and up 3. All right, last one, f of x is equal to, we moved left 7, so that's x plus 7, and we move down 2, minus 2. That's it, kids. We are done. Day 4 is bodied. That's what the cool kids say in my school. I'm cool, so I say it. All right, kids, that's it. Hit the subscribe button, hit the like button. Give me a comment. Let me know how you think things are going. Let me know if you need anything or if you've missed anything. See you, kids. Goodbye.